And here we go into sequences, some very, very cool stuff, and basically the follow-up to a study of the basics of patterns. So what are sequences? We're going to check out what they are in this video, as well as how to evaluate rules that describe sequences. Very awesome stuff. So we are told that a sequence is a list of numbers that often follows a pattern. So a list of numbers that often, and I should say, follows a pattern. Now, little asterisk right there. Each number in a sequence is called a term. So here's an example of a sequence, a very simple one. We go 1 to 4 to 7 and to 10. The pattern there is that we're adding by 3 to each previous number to get to the next number. So what does this deal with what terms are? Well, 1 we would call the first term. The second term in the sequence is 4, the third term is 7, and the fourth term is 10. It's a way for us to basically catalog or order and identify what number term we're talking about. So I'm like, if I'm asking, what is the third term? You would say, oh, okay, it's 7, right? It's in the order from left to right that we go. We often use n equals the number of the term to describe the term. So for instance, you might say that this is n equals 1, n equals 2 for the second term, n equals 3, and n equals 4 for the fourth term, right? Or the first, second, third, and fourth term. That's it. So very, very cool stuff. Eventually, you're going to be figuring out how to come up with rules for these sequences, but for now, we're going to be evaluating them. So we are told that we are given rules for 2 sequences. Find the first 5 terms and the 60th term for each sequence. Okay, so what does that mean? Well, essentially what that means is we need to figure out how to use this expression to come up with terms of the sequence, the first 5 and the 60th. And then we'll do this guy over here a little later on in the video. So what this tells us is the sequence follows the pattern that we're going to multiply the number of the term, right? N, again, is the number term. So if we have the first term, we'd plug in 1 for n. So we're going to multiply 4 times the number of the term and then subtract 1. That's the pattern. A lot of people like to set this up in a table, so why not do it that way? I'm going to set it up in a nice horizontal table here. Some people do vertical tables, so I'll show you both. So n is the number term that we're at. And then here we'll just call this, I don't know, the sequence. So I'll just call it the value, right? So that's the value that we get, value of term. So n is the number term that we're at, and then the value of the term. Okay, so the first term, what do we get? Well, all you have to do is plug 1 into there. So mathematically what I'm doing is I'm doing 4, and I'll do a little bit of side work here, times 1 minus 1. That's all I'm doing. 1 times 4 is 4, minus 1 is 3. So when I plug 1 into the rule that gives us this sequence, this pattern, I get out 3. I'm going to do the same thing now. I'm going to input 2, right? Very simple. So I'll do 4 times 2 minus 1. This is our second term. We multiply every term by 4 and subtract 1. So 4 times 2 is 8 minus 1 is 7. And I should say we multiply the number that the term falls at, not the term itself, by whatever that n value is by 4 minus 1. Here then, we go to the third term. So again, I will plug 3 in. So I'll put this over here. We do 4 times 3 minus 1. That's 12 minus 1 is 11. And then we go on to the fourth term. I think we see the pattern here. We're going to multiply 4 by the fact that we're at the fourth term minus 1. 4 times 4 is 16, minus 1 is 15. And we'll arrive at the fifth term before getting to the 60th term. Whoa. So the fifth term, that'll be 4 times 5 minus 1. Again, the number of term that we're at. What value? We're at the fifth one, so we multiply by 4, subtract 1, that's going to be 19. And last but not least, if we're at the 60th term, we multiply 4 by 60, pretty sweet, and subtract 1. It's 240 minus 1 is 239. So what is our sequence? Our sequence, if we were writing it out, was 3, 7, then another 11 after a comma, then 15, then 19, and then after a whole bunch of values, 239 is the 60th term. So that's it. We get our pattern from the sequence rule that we're given. just by plugging in numbers. It's not so bad. And again, the numbers that we're plugging in represent the place in the sequence that we are at. The first place was 3, second was 7, 11 was the third, 15 was the fourth, 19 was the fifth, and here's the work to support. If you need another example, or you're thinking, man, my teacher's giving me some examples that go beyond that, maybe with exponents, I thought to provide you with a second example. If not, this first example might suffice. You might look at that and say, dude, I am so good with this now, Mr. G. Thanks so much. Or maybe you need to watch it again and just kind of grasp it a little better. If you need that bonus coverage, here we go. So we've got a second sequence rule here, or a second rule for a sequence. It tells us to square the term number that we are at and then add 5 to that. Okay, so I'll do a vertical table here, no problem whatsoever. You know what? Yeah, I'll put the table over here. So n, and then this is the actual value of the term. Value of the term. And again, we'll start with the first 5 values. So that would be 1, then 2, then 3, then 4, then 5, and then eventually we'll go to the 60th term. Okay, if I plug in 1, here's my work. I'm going to square 1 and then add 5. 1 squared is 1, plus 5 is 6. So that means that this term, the first term, is 6. The second term, we will again evaluate. So I'm going to do 2 squared plus 5. 2 squared is 2 times 2 is 4, plus 5 is 9. Sweet. The third term, we're going to continue in this pattern, 3 squared plus 5. Simplify that down, it's going to be 14. And now we'll do the fourth term in this sequence. 4 squared plus 5. 16 plus 5 is 21. Ooh, very cool. And then we get to the fifth term. I will plug that in. 5 squared plus 5. 5 squared is 25, plus 5 is 30. So that is our fifth term. Now, if you needed the 60th term or any numberth term, you'd evaluate that into our rule. So in this case, I will have 60 squared plus 5. 60 times 60 is 3,600, or 3,600, plus 5 is 3,605. So our final sequence here, based on the outputs that I got from the inputs that I put in here, I will get that my first term in this sequence is 6, the second is 9, just grabbing it from my results here. The third term is 14, the fourth term, 21, and the fifth term is 30. And that, my friends, is some very cool rocking of rules that give you sequences. In a later video, you're going to actually be going backwards. So you'll be given the sequence and be asked to come up with this. It's a little more difficult, but something that is certainly very doable and very worthwhile in terms of later math studies.